All right, guys, time for our Unit 3 review. We're getting there. And I think you're going to like this one because if you remember the Unit 3, the atom packet, it got tough there. We had a lot of scientists to remember, a lot of information about wavelength calculations, a whole bunch of quantum numbers, and then electron configurations with a lot of rules to them. For your final, I cut down the information to the big ideas from this stuff. Went to about half the scientists. Very little on quantum numbers. You're going to see as we go through it that it's the big ideas rather than the little facts that I brought into this review. And again, if it's not on this review or one of these reviews as we go through, it's not on the final. So these couple pages I've given you in this review packet versus the 48-page The Atom packet should be a nice reprieve compared to what we already did with this. I've cut the scientists down to 6. These are the guys that did something huge or discovered a particle. Dalton wrote the first atomic theory. He's got that gas law too. We just talked about Dalton again. He thought the atom was like a marble. He wasn't quite right, and we're going to look at his theory again in a minute. Thomson, plum pudding, discovered the electron. So that's what we're looking at. Model of the atom, what particle did they discover? Dalton, marble, atomic theory. Thomson, plum pudding, electron. Rutherford discovered the proton. He realized that the nucleus was really little and positively charged. His experiment was pretty cool. He was the one shooting the positive particles at the gold foil, and the positive nucleus was kicking every so often would kick a positive particle back. So he was looking at positive repelling positive. You don't need the details on the experiment. Alpha particles, gold foil, positive repels, okay. Bohr's model, it doesn't really work. It's kind of like the stick figure version of an atomic model. It's the right idea, but not perfect because it's two-dimensional. This is the planetary or Bohr model, but he was the first to realize that the electrons were organized, that they weren't just chilling in there like plums in pudding or like jello in a fruit cup. They were moving with some purpose around a nucleus, and that's good. So you got the positive nucleus at this point with the electrons going around. The two terms from the Bohr model that we used were ground state, which is your low energy state, and excited state, proving that electrons can move around in an atom when energy is gained. Schrodinger's the big guy. He's the one that made all those quantum numbers, and the quantum model, which is mathematical, it uses equations, and that's the model we're using right now. And Chadwick discovered the neutron in the end. I threw him in there because he discovered a particle, and that's what I decided was important. No de Broglie, no Nagaoka, no Democritus, none of the smaller points on this, and not all the facts even for these guys. So we cut down to 6. And Mendeleev, of course, he's just always sort of there. We're going to look at Dalton's atomic theory. It was the first one, and it's okay. For what he knew then, it was pretty darn good. What I highlighted in red in your notes is the stuff that might not be so true right now. Some of it's debatable and some of it's not. All substances are composed of tiny indivisible particles called atoms. That's where Dalton started. Everything is made of atoms, but we can break them down into protons, neutrons, and electrons, or we wouldn't have much to talk about in this class. Atoms of the same element are the same. They're pretty close. They are the same in that every time I've got nitrogen, it's got 7 protons. Every time I've got helium, it's got 2 protons. Every time I've got barium, it's got 56 protons. The number of protons in an atom is always the same, but they can have different numbers of electrons and neutrons. Those kind of meander in and out. So you can change atoms. They don't have to be identical, but they're going to be the same in the number of protons. The atoms of any one element are different from those of any other element because they're going to have different numbers of protons, guaranteed. Remember, protons equal the atomic number, which is the whole number where you find an element in the periodic table. Atoms of different kinds can mix together. That's what they do. They make compounds. Not every element can make a compound with something else, but he didn't say that. He just said that atoms combine to make compounds, and we good there. That's true. Chemical reactions do occur when atoms are separated, joined, or rearranged. Now, this gets sticky with your definition of a reaction. Ordinary chemical reactions don't make new elements, like the stuff we can do in the lab. If you're talking about crazy things like colliding elements or reactions occurring in the centers of stars, yes, new elements are made. Elements are destroyed and broken down into smaller elements. Most people, I think, consider these to be products of physics rather than chemistry, more like a brute force thing than an actual chemical reaction, because they are. I always say that colliding the elements, like trying to make oganesson and copernicium in a collider, is like throwing jello off a wall. You heave it really hard and hope it sticks. And if it stays even for like a fraction of a second, you're awesome. That's how you make new elements. Stars use elements as fuel to burn and break down stuff and make stuff. And crazy things happen there too because of high pressure. I don't think of those as ordinary chemical reactions. If you do, you can call Dalton a liar there. He did not know those. If you don't consider those to be ordinary chemical reactions, I say no. I push those out of chemistry. Those are something else. That's for the physics guys and girls to deal with, not my problem. I say that Dalton is right on this one, that ordinary chemical reactions, what he knew about, do not make new elements. So what Dalton did was start off what we know about the atom and give us a pretty good guess. I mean, remember, he thought it was a marble. He was going with what Democritus said and got shunned in Greece over. But what you got to know so far are those 6 scientists, again, a big break from before, a couple little facts about each one, and then a review of Dalton's atomic theory, because that might be which of these parts of Dalton's atomic theory is true, which is false, what you think. Remember, there's only going to be a few questions on each topic on the final, but I want to go over all of them. We've got 2 more days of review from this packet. The next one will be on our wavelength and frequency calculations, and the one after that on quantum numbers and electron configurations. So, hang in there. There are no practices for you to do today, but I've got this information for you to check out. Have a good one.